Hello again, it's me. I'm here to kind of walk you through dimensional analysis or unit analysis. And the first thing that comes to mind is, well, what the heck is dimensional analysis? What are you talking about when you say dimensions or units? When we're describing a dimension or a unit, we're basically giving a number an adjective to describe what that number means. So, a dimension or a unit, I'm talking about meters, liters, grams, miles, hours, or so on, or seconds even, okay? So when you have a number, you're assigning that number a unit to tell exactly what that number is measuring. As far as the analysis piece goes, when we're dealing with dimensional or unit analysis, we're essentially trying to convert one measurement that's in one type of, unit system into a number of a different type of unit system to make it a little bit easier to deal with. Dimensional analysis is going to come up in honors physical science and honors chemistry and regular chemistry in dealing with metric conversions on a very base level, and then going normally between metric and English conversions, and then for the chemistry we're going to use it in something called stoichiometry and mole math. So this is a skill that you're going to need to know, and it's not going to go away. If you remember when you're dealing with metric conversions, and we're dealing with King Henry died by drinking chocolate milk, we can easily slide the decimal to the left or the right to give us our metric conversion. So in the problem below, you've got 50 centimeters and you're being asked to convert it to kilometers. The easy method would be that you'd start at centimeters and we would count the jumps all the way up to kilometers. So I'd jump once, twice, 3, 4, 5 times. I've jumped 5 times to the left, which means that I'd have to move my decimal 5 places to the left. The decimal naturally is going to sit after the 0 for the 50, and I'm going to move it 5 times. And when I include my zeros, my answer is going to be 0.0005 kilometers. That's pretty easy. And for dimensional analysis, you normally would not use this type of problem for dimensional analysis because you can easily slide the decimal back and forth. But we're going to use this as an example to try and walk you through what a dimensional analysis problem would look like with an easier example that you can go and check on your own. So in beginning a dimensional analysis problem, I'm going to make this a little bit longer because I want to make it easy to understand where I'm making my connections. For a dimensional analysis problem, if I'm going to do the conversion of 50 centimeters to kilometers, and I'm going to use dimensional analysis, the first thing that I have to do is I have to make some kind of connection between centimeters and kilometers. In order to do that, what I'm going to do is I'm going to start at my centimeters, and I'm going to try and make a connection between centimeters and meters, and that's going to happen in this first step. And then I'm going to make a connection between meters and kilometers, and that's what I'm going to include in my second step. So, when I'm looking at my problem originally, I started with 50 centimeters because that's what I was given in my original problem. I can either write my 50 centimeters as is, or I can put a 1 there and make it into a fraction. And when I'm looking at it in a fraction, I need to understand that my centimeters are in the numerator, and I want to eventually get rid of those centimeters and eventually change it into kilometers. But what I'm going to do is I'm going to use that first conversion from centimeters into meters. So then I look at it and I say, okay, well, what kind of relationship is there? If I'm dealing with meters and centimeters, well, if 1 meter is related to a centimeter, in what manner is it related? Well, 1 meter equals 100 centimeters. I'm going to use that equality statement and place it in my equation. Because centimeters shows up in my numerator, I want to put centimeters in my denominator. Because ultimately I want that to cross cancel out. And because I'm using this equality statement, then that means that meters needs to be in the numerator. And I'm using 1 meter equals 100 centimeters. So that deals with this jump. I've taken care of my first jump, and I've also used this equality statement, and I'm good. Then the next jump is going to be from meters to kilometers. So now I'm going to go meters to kilometers. Now the question becomes is which one do I put the 1 by? Well, I'm going to choose the unit that's larger. A kilometer is larger than a meter, so 1 kilometer is going to be equal to 1,000 meters, and I know this to be true. So that's my second equality statement. Well, I have meters in my numerator, and I don't want to end up with meters, so now I'm going to put units of meters in my denominator, and I'm going to use kilometers in my numerator. Then I'm going to plug in my numbers. 1 kilometer equals 1,000 meters. And it looks like my problem is set up. But I need to go back and I need to check just to make sure because, well, you know, we make mistakes. So how do I do that? I go and I double check on my units. Not my numbers, but my units. My units should cross cancel. Centimeters cross cancel from left to right. Meters cross cancel from left to right. I'm left with kilometers. That's the unit I wanted to end up with. So I'm happy there. And now I'm left with just dealing with my numbers. So in my numerator, I have 50 times 1 times 1 all over 1 times 100 times 1,000. And when you finish all of that up and you run the math on that, if I am not mistaken, it should be 0.0005 kilometers, which was the exact same answer that you had when we just moved the decimal. So you can see why we don't use dimensional analysis in general when we're doing metric conversions because, well, you just don't need to. An example where you would do this is where you would change something like 70 miles per hour into meters per second. So now we're not talking about just going from an English unit to a metric unit. We're talking about going from 2 English units to 2 metric units. So, how do we do this? You start with what's given. You're only given one number, so that's what you start with, at 70 miles per hour. Now, anytime you put in the term per for one of those lines, that actually means divided by. So always keep that in mind because you're dealing with a rate there. And then we have meters per second, which is what we're going to end with. So I'm going to choose to convert my time rather than my distance first. So I want to convert my time, and I want to change hours into seconds. So since I want to get rid of that hour, I'm going to put hour in my numerator, and I need to make a connection between an hour and a second so I can end up with that same unit at the end. 1 hour is obviously larger than a second. So I have to make my equality statement. 1 hour equals how many seconds? And no, it's not 60, it's 3,600. So I've got my time dealt with because this hour is going to cancel. And my second, again, shows up again at the end. So we're happy there. But then the next part, I need to change miles, which is here, to meters. So since miles is ending up in your numerator and you want to change it to your denominator because you want to get it canceled out and you want to end up with meters, so I'm going to have meters in my numerator. Because a mile is larger than a meter, I'm going to make 1 mile and I guess that should be mile instead of miles. 1 mile equals a certain number of meters. If you run track and you run the 1600, you're running a mile. And there's a more exact number for that, but I'm okay with going with that general number for right now for the conversion. I double check to make sure I've got it set up correctly. Miles cancels. I'm left with meters. I'm good. So you're left then with the math. So you take 70 times 1 times 1600 and you divide it by 3600, multiplied by 1, and if memory serves me correctly, I do believe this comes out to be 31.11 meters per second. And that is how to do a general dimensional analysis problem.